Okay, section 2. This deals with the San Andreas fault system. It deals with principal earthquakes. It shows that there is in fact a 19-year cycle known as the Metonic cycle, and it proves when principal earthquakes are not triggered. Now, what does the Metonic cycle mean? Well, let's start with the 18.6-year cycle. That cycle indicates when we can accurately predict there will be eclipses. And because it's so accurate, we know that the Earth comes back into alignment with the Moon a particular way. Every 18.6 years, it comes back so that we can figure right where it'll be. The 19-year cycle has this about it. Every 19 years, my fist will represent it. Every 19 years, the Moon comes directly back in over the same area of the Earth. Now, let's see if I can get it to just hold still. Okay, so let's say that's Mexico City. So here we are, right over Mexico City. It'll be 19 years before the Moon in all of its circuit will come back directly over Mexico City. The difference is, unlike the 18.6-year cycle, where it will be specifically the same distance from the Earth, this one is variable. It's variable. It can be way out here at apogee, it can be in close at perigee, it can be anywhere in between. And that's why on specific years it's unlikely that there will be, it's one of the reasons why, it's very unlikely that there would be a principal earthquake triggered. Because if it's far enough out, when it comes directly over, it makes a difference. When you bring in the studies of earth tides, it used to be people thought the Earth rose just a few inches in relation to the Moon. No. It comes across North America at about 18 inches. 18 inches of rise across North America. And it's as though, and now I'm going to use the flashlight to get the point across, if the Moon is right here, now the highest it can come is about 28 degrees. So you're just looking at where will be the closest point in 19 years. The same thing for when you trigger the earthquakes. Somewhere in that year it'll keep coming closer and closer to that spot. And if on one of those occasions it's directly in line and at a decent distance, it has to be nearer to perigee, it produces the greatest pull on that particular part of the Earth. Scientists have discounted gravity for a long time because it's such a minute force in relation to the strength of the Earth. But, as we'll soon see, it's very effective. Though it may be small, that's relative. You know, you can have a person that's small in relation to Arnold Schwarzenegger. He could be 5'10" and weigh 280 pounds. He's still small compared to Arnold. Okay. How does it work? How does it differ from the 18.6-year cycle? It has to do with latitude. You see, the closest point that you're going to be, if you know about tidal models where you have your tides for ocean, or if you read tide tables, when you have a perigee, if the Moon is at the equator, further up, well, you might have moderate tides here. Let's say at San Diego, maybe they're going to be 5.5 feet. But if it's at the full 28 degrees, the same distance for perigee, and you may have 6.5 or 7 foot. I know we have 7 foot up in the northwest where I live. So let me show you something that's really interesting. There is a second cycle buried in the Metonic cycle that affects earthquakes. A second cycle, not just one. And it's probably one of the reasons it's so tough to figure this out. So I'll move in, make sure that this is a decent distance where you can see it. At the equinox, near the equinox, the two time periods shown, there are no principal earthquakes that have ever occurred, not in 200 years of history, along with the other 200 years. It is just a fact. You can check the dates yourself, as I did, and I find it phenomenal that it represents nearly 5 months. It's more than 4.5 months when principal earthquakes are never triggered. Never triggered. And this proves it's the Metonic cycle. It proves that it relates to syzygy, with the moon being closer, as at perigee. Perigee is like saying fast. If you're an old Yugo driver, I never owned one, but if you're going fast in a Yugo, I assume that'd be 65, 70. But if you're going fast in a Ferrari, 65 or 70 is hardly idling. So perigee changes. There are certain times a year, around July and August, when all bets are off. You do not have the closest perigees. But when you have perihelion, when we come closer to the sun, the Earth comes closer, the physics say that it draws the moon in closer. So then your perigees are very close. Now what does that mean? 2/3 of all principal earthquakes occur during 1/3 of our revolution around the sun. And you can guess when. That third is when we come closest to the sun. I don't see how the scientists missed this that long or couldn't see it. It's really obvious. So that's the proof of the gravitational effect, syzygy or the lack thereof. These all account for some of the variables. One of the other variables that also enters the equation is if a fault is not under enough pressure, stress, then when the moon comes in, even with a close perigee, it may not go off. So you have two variables, which brings us on to some other little interesting details. Let's take Mount St. Helens, the eruption, 1980. The volcanologist predicted it would go off in a certain time span because of the close perigee we were going to have that May. Northridge, after Northridge, 2 succeeding months we had close perigees. Both times we had large aftershocks. Then there's the fact that when our astronauts went to the moon, they registered lunar quakes at perigee. Lunar quakes, and the moon's supposed to be solid. How did it have earthquakes up there? Well, it didn't. It had lunar quakes. Okay, so these proofs add up, and they show that this 19-year cycle is affected by gravity. It's affected by the stress in the Earth's crust. You know, why doesn't it happen further out in the solid part of California? Why is it always just along the ring of fire? It opens up some interesting questions. Okay, so in the next section I will cover these variances. Why not every 19 years? Why not exactly 19?